Mathematics is a language of the universe. It allows us to explore the cosmos from the smallest particles to the largest galaxies. Sometimes this exploration leads us to unexpected places, realms that seem beyond our comprehension. One such realm is the world of complex numbers. At the heart of this mathematical landscape lies the work of Rafael Bombelli, a 16th century Italian mathematician. Bombelli's insights revolutionized algebra and paved the way for countless discoveries. Bombelli dared to venture into the unknown. He wrestled with mathematical concepts that his contemporaries found perplexing. He embraced the seemingly impossible, laying the foundation for the modern understanding of complex numbers. These numbers, with their imaginary component, once seemed like mere mathematical curiosities. Today, they are essential tools in fields ranging from physics to engineering. Bombelli's story is a testament to the power of human curiosity. It reminds us that the pursuit of knowledge can lead to unexpected breakthroughs. His work demonstrates that even the most abstract mathematical concepts can have profound implications for our understanding of the world. He challenged the conventional wisdom of his time, expanding the boundaries of mathematical thought. By daring to explore the realm of imaginary numbers, Bombelli opened up new avenues of mathematical inquiry. His work laid the groundwork for future mathematicians to build upon. He transformed the way we think about numbers and their relationships. His legacy continues to inspire mathematicians and scientists today. Rafael Bombelli was born in Bologna, Italy, in 1526. His family was of modest means, but they encouraged his intellectual pursuits. Bombelli's father, Antonio Mazzoli, was an architect. He instilled in his son a practical approach to problem solving. This practical mindset would later influence Bombelli's mathematical work. Bombelli did not receive a formal university education. Instead, he was apprenticed to Pier Francesco Clementi, an engineer-architect. This hands-on experience shaped his understanding of mathematics. He learned to apply mathematical principles to real-world problems. This practical approach would become a hallmark of his mathematical work. The Italian Renaissance was in full swing during Bombelli's formative years. This period of intellectual ferment exposed him to a wealth of knowledge. He studied the works of prominent Italian mathematicians such as Niccolò Tartaglia and Girolamo Cardano. Their work on cubic and quartic equations sparked Bombelli's interest in algebra. Cardano's Ars Magna, a seminal work on algebra, particularly captivated Bombelli. However, Cardano's treatment of imaginary numbers left Bombelli wanting more. He saw an opportunity to delve deeper into the mysteries of these enigmatic numbers. This curiosity would drive his groundbreaking work on complex numbers. Bombelli's magnum opus, L'Algebra, was published in 1572. This comprehensive treatise revolutionized the field of algebra. It introduced a systematic approach to complex numbers, a concept that had baffled mathematicians for centuries. The book was divided into 5 parts, each building upon the previous one. The first part of L'Algebra covers fundamental algebraic operations. Bombelli explains addition, subtraction, multiplication, and division with clarity and precision. He also introduces the concepts of powers and roots. These foundational concepts form the basis for the rest of the book. The second part delves into the solutions of quadratic, cubic, and quartic equations. Bombelli builds upon the work of his predecessors, including Tartaglia and Cardano. He refines their methods and offers new insights into the solutions of these equations. This section demonstrates his mastery of algebraic techniques. The third part is where Bombelli truly breaks new ground. He introduces the concept of imaginary numbers, referring to them as sophisticated numbers. He develops rules for manipulating these numbers, establishing the foundation for complex arithmetic. This section is the heart of Bombelli's contribution to mathematics. The fourth and fifth parts explore the properties and applications of complex numbers. Bombelli demonstrates how these numbers can be used to solve previously intractable equations. He reveals the practical significance of complex numbers, solidifying their place in the mathematical landscape. This completes his comprehensive treatment of complex numbers. The Bombelli's most significant contribution to mathematics was his systematic treatment of imaginary numbers. Prior to Bombelli, mathematicians struggled to make sense of the square root of negative numbers. These quantities seemed to defy logic and were often dismissed as nonsensical. Bombelli, however, recognized the importance of these imaginary numbers. He realized that they held the key to solving certain types of equations. He developed rules for adding, subtracting, multiplying, and dividing imaginary numbers. These rules transformed the way mathematicians thought about numbers. He introduced the concept of the imaginary unit, denoted by I. He defined I as the square root of -1. This seemingly simple definition had profound implications. It allowed mathematicians to manipulate imaginary numbers with the same rigor as real numbers. This paved the way for the development of complex analysis. Bombelli's rules for imaginary numbers were groundbreaking. They provided a framework for understanding and working with these previously enigmatic quantities. His work laid the foundation for the formalization of complex numbers in later centuries. This paved the way for their widespread use in mathematics and science. Now, let's talk about the practical applications of complex numbers. You might be wondering, where do these abstract mathematical concepts fit into the real world? Well, complex numbers play a crucial role in various fields, such as engineering, physics, and even in computer graphics. For instance, in electrical engineering, they are used to analyze AC circuits. In physics, they help in solving wave equations. And in computer graphics, they enable the creation of intricate fractal designs. So as you can see, complex numbers are not just theoretical constructs. They have real-world applications that impact our everyday lives in significant ways. Rafael Bombelli's work laid the foundation for future mathematical discoveries. His innovative approach to complex numbers opened new doors for mathematicians, allowing them to solve problems that were previously deemed unsolvable. Bombelli's influence is evident in the way modern mathematics approaches complex equations and algebraic structures. Complex numbers have become a fundamental tool in science and engineering. From electrical engineering to quantum physics, Bombelli's contributions have made it possible to model and solve real-world problems with greater precision. His pioneering work continues to resonate in fields that rely on complex number theory to advance technology and understanding. Even today, Bombelli's impact on mathematics is undeniable. His methods and theories are still taught in classrooms around the world, inspiring new generations of mathematicians. The elegance and depth of his work ensure that his legacy endures, reminding us of the power of innovative thinking in the face of mathematical challenges. As we celebrate Rafael Bombelli, the father of complex numbers, we honor a visionary who transformed mathematics. His contributions have not only shaped the field, but have also paved the way for countless advancements in science and engineering. Bombelli's legacy is a testament to the enduring power of curiosity and intellectual bravery.